In this training video, we'll take a look at how to make a sound intensity map and how to calculate sound power using the sound intensity application on the 2270 sound level meter. In the 2270 sound intensity application, there are three main modes that we can select at the top right. First is the sound power and mapping mode, which we can use to calculate sound power to a variety of selectable ISO standards, or we can create a sound map with sound intensity measurements. The map can be shown over a picture of the test object directly on the meter. We can do both of these at the same time. We can also check the temporary variability of the system to determine how stationary the source is. This is the F1 indicator in the ISO 9614-1 standard and can be performed here as a pretest before you do the sound power determination. The compass mode is a very simple application that will allow you to quickly detect whether sound is coming from the front or the rear of the intensity probe. If I select compass, we'll see the screen display a picture of the probe. The speaker indicates that most of the sound energy is coming from the front or the rear of the probe. This can be very useful for leak detection. For example, if we are scanning the probe horizontally across a source, we can slowly move the probe across, and as the probe passes the sound source, we will see the sound direction change to indicate the location of the leak. Notice that as the probe moves across the sound source, the speaker will move to indicate whether the sound source is behind or in front of the probe. If we move the probe parallel to the surface, horizontally and vertically, we can identify a sound leak that is a point in the XY plane. If we go back to the sound power and mapping mode, we can look at the third octave band spectrum of the sound intensity probe. The direction of the sound in third octave bands is indicated by the color of the band. White represents sound flow in the positive direction, and green represents sound flow in the negative direction relative to the probe. Here we can see we have a sound source coming from behind the probe. The sound intensity application is a lot like other applications on the meter. We can go to the main menu at the lower left to enter Setup so we can set up our measurement. First are the input parameters where we can select and verify that we have the sound intensity probe selected, the 4197 microphone pair, and also what spacer we are using. The default spacer is the 12mm spacer, but we might use a different size spacer for different applications. We can also select the range setting. The sound intensity application has two ranges, high and low, for different levels of noise sources. If we're measuring a quiet source, we would use the low range, and if we have a moderately loud or louder source, we would use the high range. Next, we can select what standard we'd like to measure to. If we're making a sound map or a general sound power determination that isn't tied to a standard, we don't necessarily have to select any particular standard, and we could leave the selection set to none. If we want to make a measurement according to a specific standard, we can select that standard, and the required calculations and procedures of that standard will be followed in the measurement. For example, if we select ISO standard 9614-2, the ISO scanning method for sound intensity-based sound power determination, we'll be required to make 2 scans of each segment, because that is required by the standard to determine the repeatability of the measurement. There are different grades of accuracy that we can select: survey, engineering, and precision grade. The test methodology is generally the same for all three, but the tolerances for repeatability and other factors are tighter as you move to engineering and then to precision grades. For this demonstration, I'll select survey. Next, we can specify the bandwidth of the measurement. Third octave measurements are most common. Under measurement control, we can also select the sound intensity task as we did before on the main screen. Like other applications on the meter, we can select manual or automatic mode to allow us to control the duration of the measurement with the start and stop button, or to automatically stop the measurement after the predefined time. The ISO 9614-2 standard requires at least 20 seconds per measurement. We can predefine the measurement segment order in a geographic fashion so that we can easily move to adjacent sections of the measurement if we have our measurement sides subdivided, as we would for mapping. Next, we can define the measurement surface. When we make a sound intensity measurement, we measure a reference surface area. A box is the default measurement surface type, and it will treat the measurement surface as a 5-sided surface with a front, left, right, back, and a top. If we select Custom, we can select a wide range of surfaces, each with different dimensions. For this demonstration, I'll be measuring a loudspeaker that is the shape of a box, so I'll use the box surface type. I'll enter the correct measurement surface height and width, so the sound power calculation is based on the correct area of the measurement surface. For this demonstration, I'll measure close to the surface of the sound source in order to make an intensity map. For most true sound power determination measurements, you won't be measuring very close to the source surface. We can select a number of rows and columns for each surface in order to subdivide the measurement. Most standards only require one segment per side, but if we want to make a noise map, we'll need to select multiple rows and columns, and I'll do that for the front. You should select at least 3 rows and 3 columns for sound mapping. If you select more segments, your measurement will take longer, but you'll achieve better spatial resolution on the noise map. We can make a recording with the sound intensity probe if we have the recording option on the meter. As with other applications on the meter, there are also options for the output socket signal, headphone signal, and generator output. Next, we can take a picture of the measurement object with the camera on board the 2270, so that we can map our defined measurement surface to the object itself visually. We can do that by going to the Surface tab, and then clicking on the camera icon to take us to the Annotations menu. In the Annotations menu, we can select an existing picture to select for the surface, or we can click on the camera icon at the top to turn on the camera on the meter to take a new picture. I'll go ahead and do that. The camera view is displayed on the meter screen, and I'll line up the speaker in the viewer. I'll click the Manual Event button to take a picture, and then the Confirmation button to save the image. When we have the image saved, we can specify which portion of the picture is related to our measurement surface. To select the picture for the surface, we'll drag the stylus on the screen to mark which portion of the picture will be used for the measurement surface. When we close the window, we can see that the picture is now shown in the Surface tab for the selected measurement surface. Now we can start making our measurements. We can select what side we want to measure by selecting the surface from the drop-down menu at the top left. Notice that for the left side, we don't have a picture, and we've only selected a 1x1 measurement grid, so we have just one measurement to make. In this example, I'll be calculating the sound power of the speaker output according to ISO 9614-2, as well as making a sound intensity map of the front of the speaker. We're able to do a sound map of the front of the speaker because we've selected at least 3 rows and 3 columns for that surface. I'll turn on the speaker and we can go ahead and make some measurements. For this demonstration, I'll be playing two tones through the speaker, one at a low frequency that will come through the woofer, and one higher frequency that will come through the tweeter. I'll scan the probe perpendicular to the surface and over the measurement surface segment that is highlighted with the red box. The measurement is started by pressing the Start and Stop button on the meter. We can see the duration of the measurement at the top left, which is important if we're trying to make a sound power determination to one of the standards. It'll inform us if our measurement duration will satisfy the requirements of the standard we have selected. The frowning face at the top right of the screen will disappear once we've reached 20 seconds, which will indicate that we've satisfied the requirements of the selected standard. The standard I have selected requires a second scan for each segment, so I'll go ahead and make that second measurement. Once both scans are complete, I'll click the Save button to save the measurements. I can now proceed to measure the other segments. Now that we've completed the measurement of the front side, we can either proceed to measure the other sides by selecting them from the drop-down menu at the top left, or we can click on Result to calculate the sound intensity map of the front side. The Results section has three tabs at the bottom. The Spectrum is where we can view the third octave sound intensity results for any segment. The white bands represent that there is dominant sound energy coming from the sound source, and the green segments represent that the dominant source is from the background. The Surface tab will allow us to look at the results for any of the sides. The results can be shown as a numerical value for each segment, or we can calculate a map with curves or contours by selecting the menu at the top right. The default display shows the overall A-weighted energy on the measurement surface. We could also select to display the map of any particular third octave band result. If I select the 250 Hz third octave band, we can see that the woofer is the dominant noise source. The Total tab will allow us to view the total results for the entire object. Here, we see the overall sound power result of the 250 Hz band for the front of the measurement surface. The total A-weighted power is also displayed at the bottom of the screen. We can exit the Results section and return to making measurements by clicking on the red X at the top right. Let's proceed to scan the other sides so that we can complete the sound power determination of this speaker. Now that we've measured each side according to the selected standard, we can click on a result to look at the total sound power for the whole test object. We can select a specific third octave or the overall A or Z weighted result from the drop-down menu at the top. We could also select to display other parameters from the drop-down menu at the top left. That's a brief introduction to the sound intensity application on the 2270 sound level meter.